Hi, everybody, and welcome to the Kubernetes Multi-tenancy Working Group. Today we have two presentations. The first one is going to be by Bharat Sanal on the EdgeNet Kubernetes Distributed Cloud, and the second one is going to be Daniel Sover talking about the operator Lifecycle Manager and multi-tenancy related problems. So going to hand it over to Bharat to kick us off.
Hi, everyone. My name is Timur Friedman. I'm on faculty at Sorbonne University. As Bharat mentioned, I lead the team, but Bharat is doing all of the interesting work with Kubernetes. Thank you for having us. We're new, we're eager to join and to learn, and we'd like to start off by telling you about what we're doing with EdgeNet. So we come from the university research world. EdgeNet is the latest in a long line of global networking research infrastructures. We run Planet Lab Europe out of Sorbonne University. There's the Seattle infrastructure. Justin Kapos at NYU Tandon was instrumental in that. Genie infrastructure funded by National Science Foundation. Fed for Fire here in Europe, the Savvy infrastructure. These are all highly distributed infrastructures for research and networking open to the public internet. I know that edge can mean a lot of different things to different people, so let me just situate for you where we are. We are in the wired edge, and we are behind the distribution network. Our machines are typically racked servers at research institutions. They can also be VMs on people's at home. So unlike earlier research infrastructures, which were based on distributing hardware, we distributed several hundreds of servers around the world with Planet Lab. Here we really have a viral potential, sorry to use that word at this time, because of the ability to install using software. If you could just go back one slide, Barrett. Installation of EdgeNet nodes, super simple. Anybody can just bring up a Ubuntu or CentOS VM and in minutes have an EdgeNet node running. Next slide. And then what we are leveraging is the fact that there's such a wide base of people who know Docker and Kubernetes. In the past, well, us with Planet Lab Europe, we were using Linux vServer. Then we moved to LXC, Linux containers, kind of rolled our own control frameworks. Here, we're using things that everybody knows. So what we aim to have as a research infrastructure for our community is EdgeNet nodes within 5 milliseconds of anywhere, as opposed to the cloud today in data centers, 30 milliseconds to anywhere. Today we have, well, this number varies, but we have about 55 nodes around the world, mostly in North America and Europe. And we're signing up new members on a regular basis. So here to talk about multi-tenancy. EdgeNet is multi-provider and multi-tenant. So people provide the VMs on which the nodes are deployed. They can be individuals. They can be, that's our typical model, research institutions, universities, laboratories, anybody who has a machine that's connected to the internet, they can offer nodes. Then the multi-tenant aspect is that we have researchers around the world who use this system. Also, they open it to the classrooms. So there might be dozens of students in a classroom who are deploying experiments or lab exercises on a worldwide scale. And all of this is mediated by EdgeNet Central. So what we're here for today is to enter into dialogue with you. We want to know who's facing issues that are similar to the ones that we're facing. We're eager to combine our efforts with others. For instance, we have a monthly meeting with people at Measurement Lab at Google in New York City, where they're developing a similar system. They have deployed a similar system. We have a monthly meeting with them where we share return on experience. We're not sharing code with them yet, but we might move in that direction. We're interested in finding others who are similarly motivated. And now I'll hand it over to Berat. Berat, you have to unmute.
Hello, everybody. This is Berat who is speaking. I'm going to talk about what and how we have done so far and what we want to have in the next steps. So firstly, we want to contribute back to the Kubernetes community. So because of that reason, we switched to programming language we used in the first version of EdgeNet to Go language. And for now, we use custom resource definitions to extend Kubernetes API. In general, we focused on two principal dams. One of them is bringing Kubernetes into the edge computing and enabling multi-tenancy in Kubernetes. Let's have a look at our architecture. So, as you know, this is a standard custom source definition architecture. Custom source definitions, which uses the main Kubernetes API server handling custom resources in the same way they do to handle core resources like pods and daemon sets, as you see in the figure. So we have plenty of CRDs in use, such as selected deployment, authorities, users, teams, slices, and so on. I wanted to talk about the CRDs because I want to discuss the problems we encountered further after the presentation. So in the first place, as Timur mentioned, when we say edge, we don't mean device edge. So the devices such as smartphones, laptops, and sensors that really have limited spare compute and data storage capability with connectivity problems yet. So by saying edge cloud, we mean cloud-like capabilities located at the infrastructure edge. So EdgeNet has established a Kubernetes edge cluster that the edge nodes are located in distributed locations by getting the benefit of a feature that makes it easy for third parties to add nodes into cluster. So a feature that EdgeNet offers to the users is selective deployment that basically provides location-based node selection. This feature allows users to do so based on continents, countries, states, regions, and cities, as well as polygons described using latitudes and longitudes.
Sorry, can I just ask a quick question on that one? So do you is the intent to offer a single global cluster of which all of the different regions are represented by attributes on the nodes, or are you going to have, for example, regional clusters that can span, for example, like a continent or part of the continent or something like that?
We know it's very hard to manage a cluster which exceeds 5,000 nodes, but for now we want to grow up and reach that numbers. And then if it will be necessary, we might talk about federation, doing federation to create regional clusters. So
okay.
For now, our goal is creating one cluster. And
a one planet-wide cluster.
Yeah. When we exceed that number, of course, we need to discuss doing federation or that kind of solutions.
Okay, thanks.
You're welcome. So two principal dams we developed a multi-tenancy model in EdgeNet by inheriting the concepts mainly from Planet Lab. Site is a physical location where Planet Lab nodes are located, whereas an authority in EdgeNet is not required to provide a node, but they both own users and slices. Additionally, authorities in EdgeNet have an added feature called team, inherited from Fed4Fire, which established federated testbed infrastructure in Europe. In Fed4Fire, it is called projects. Before explaining them, I want to mention that authorizations to use EdgeNet are handed out hierarchically so that authority admins approve local users who they know. The central admins of EdgeNet approve the establishment of authorities, each authority having its own local admin. An authority admin approves the creation of individual user accounts. So they can create teams and slices and also can change the user role as manager and tank. At this point, I want to mention that in the next versions, we will create a permission CRD for authority admins to delegate responsibilities independently to the users, giving admin privileges independently. But for now, authority admins can delegate user approval, creation of team and slices to managers. And techs are the responsibles for the nodes that are contributed by that authority to the EdgeNet cluster. And a user is anyone, just anyone who develops and deploys applications on EdgeNet. Slice term, a slice is a set of allocated resources distributed across Planet Lab, and to most users, a slice means Unix shell access to certain Planet Lab nodes, whereas a slice means a set of allocated resources on the cluster in EdgeNet. We plan to enable node allocation in slices in the next releases. So team groups users to give them permission to create slices independently than admins. Before I forget to mention that there is a CRD called email verification, and that allows users to verify their email addresses during authority registration or user registration. So let's look through the multi-tenancy aspect of EdgeNet. Here is a typical Kubernetes case. We have a cluster admin. That admin creates namespaces to be used for different tasks by different user groups. As we see, namespace ABC have been created. Service accounts needed to create to be created in the cluster. Therefore, our admin created that for users, and the kubeconfig files have been delivered to users separately. Now the users can make use of namespaces according to their authorizations of service accounts. Before, I forgot to say, a token in kubeconfig file carries service account information. So what is the problem? The problem is this is not scalable. We cannot do that for thousands of users. And here EdgeNet offers a solution. Think about the use case of EdgeNet with the edge nodes located in distributed locations like Kubernetes. We have a cluster admin. Here we go. In this case, our cluster admin doesn't do anything at the beginning. Authority admins, which are admins of authorities, make registration requests for their authorities by using kubectl or the portal that we will develop by extending Kubernetes dashboard. When a registration request has been made, EdgeNet sends an email including a one-time code for the email verification. The reason is we don't want to struggle with fake registration requests. At this point, there is no notification arrived in the email address of the EdgeNet cluster admins. Then authority admins verify their email address by using their one-time codes they receive by email. They need to do that in 24 hours, otherwise the system destroys that one-time code. So this is the time our cluster admin needs to take an action, because the admin gets a notification about the authority registration requests since authority admins verified their email addresses. The only thing that the cluster admin does is approving the requests in 72 hours. It is that easy. There is nothing to do manually. So what happens after the approval? The authority request controller creates an authority object according to the request data. When an authority is created in EdgeNet, the controller generates a namespace by combining the authority name and the string of authority as a prefix, then sets a resource quota in it to prevent deploying application in this namespace, and creates an authority admin user. Herewith, the authority controller sends a notification that says your authority registration is successful. And in this email, it includes user-specific config file. So authority admins can now start using EdgeNet with that config file, and they are ready to welcome user registration requests on their authorities. So likely authority admins have been done, but with a difference. Users make registration requests on authorities that already registered in EdgeNet. And again, the same procedure, email verification. And when users verify their email addresses, authority admins get notified about the registration request. Of course, an authority admin gets notified about the users who made registration requests on the authority that authority admin registered in. Here, authority admins approve the users, and users get notified that the registration is successful. So users can now start using EdgeNet as well by using their kubectl files delivered to their email addresses. But it is not allowed to deploy applications in authority namespace. So thanks to the resource quota. There are two solutions to that. Let's start with team one. Authority admins or managers or authorized by cluster admins can create teams by choosing users from different authorities. When a team is created, the team controller generates a namespace and sets the name by combining authority namespace and the team name. But still, it is not allowed to deploy applications in team namespace. So that takes us here. Users participating in a team namespace can create slices by choosing users from different authorities. When a slice is created, slice controller generates a namespace the same as the team controller does, but it sets a resource quota depending on the slice profile. And in this slice namespace, users who participate in that slice can deploy their applications. So there's a shortcut. Authority admins and managers can directly create slices in authority namespace, as you see. Then the participants can deploy their applications. I want to show how our node contribution CRD works. As Timur mentioned, our node providers need to install an Ubuntu VM or CentOS VM, and then they just need to put EdgeNet SSH public key into that virtual machine. So when the VM is ready, they prepare a YAML configuration file including node name, IP address, port, SSH user, and node availability information. That's it. controller creates a SSH client and to install Docker, Kubernetes, and necessary packages. It also creates a kubeadm join token and run the join command remotely. Our node is ready to use. In this alpha version, if a node gets crashed, it also starts a recovery procedure that contains clean installation as well. Authorities also can enable or disable scheduling on the nodes that they contribute to the EdgeNet cluster by updating that node contribution object. When they do that, the controller automatically disable or enable scheduling on that node. So in the future, we want to create a consumable resource right to provide justice among the users. And as I mentioned, we want to provide a node allocation in slices. Because of the constraints of CRDs, we want to shift certain CRDs into API aggregation to provide better user experience. And service migration in selective deployment, lightweight Kubernetes, and accountability. So I'm sorry if it took more than we thought. So thank you so much for listening to me.
Hey, Barrett, thanks for the presentation. So do you have mechanisms for handling the logging, monitoring, alerting for each tenant separately?
So we don't have a system to monitor each tenant separately for now, but the separate service accounts would allow us to develop this feature. But for logging, so because of the namespace isolation, they log into cluster separately. So we can provide that isolation.
And if I might add a word on that point, a feature that we have not yet incorporated from Planet Lab, but which we will need to do, is the logging of all packets that enter and leave each node. In running Planet Lab Europe, since it's completely open to the internet, and since people run all sorts of odd experiments, we often get queried by network operators and owners of intellectual property about the sort of traffic that they're seeing. And we need to be able to link back to whoever is at the origin of that traffic. And so on Planet Lab, we have this type of logging of every single packet that enters and leaves. We can tie it back to the tenant who's responsible for that.
Okay, and just one more basic question: what is slice here in your context? Is it like a virtual sort of some distinction within the namespace or some CRD? What exactly is slice?
Oh, slice is a CRD which creates a namespace by setting a resource quota in this version. By getting the benefit of admission controller, we also want to provide node allocation in slices, which means, for example, when an admin creates a slice by including certain users, they will be able to select the nodes that they can deploy their applications through. So but basically, it is a CRD which creates a namespace by constraints. We can say that.
Okay, so you have like a slice operator or something to take care of?
Yeah, that's
okay.
it.
So this is Adrian speaking. I've been leading the hierarchical namespaces project. And it sounds like there's a little bit of overlap there, maybe not a ton. We're more for the sort of case of teams than individual owners. it's kind of funny. I feel like I haven't really heard many people in the multi-tenancy group talking about things like end user identity and stuff like that. I feel like, even though technically it certainly is a kind of multi-tenancy, I feel like usually we end up talking about more like teams or applications rather than individual users. But for the teams, and to a certain extent for the slices as well, I'd be interested if you want to check out the hierarchical namespace controller, HNC, and let me know if you think that that could fit anywhere into your project. Just any questions? I have one more comment, but any other questions on that before going?
Hi, Adrian. So thank you so much for informing us about that. Of course, this is why we wanted to join this working group. So to contribute back to the community and get help from the community. So I'm curious. You mentioned that you didn't look from the aspect of individual users in the multi-tenancy working groups. So
that's just a matter of this.
reason?
Sorry, what's that?
So what was the reason? So
oh, just that it's well covered in other SIGs, I believe. Can anyone chime in if they know the correct answer to this? But for example, there's a whole system of identity providers and integration into identity providers. I'd imagine that goes through SIG security for end users. I don't feel like we discuss it much in this group. Or does anyone else want to disagree with that, if I got the wrong impression?
Kubernetes, for as much as I can tell, really has outsourced kind of the identity stuff to external things. So I don't think there's been much discussion about internalizing that.
Yeah, that's interesting. This is the first time I feel like I've seen it internalized, but like there's a system of identity providers, like it's an extension point for Kubernetes. Okay, that was just, I was interested by that because we don't often discuss that here. And so I guess what I would say to Berat and the other contributors is that if you're interested in more there, maybe we can take this up on the Slack or on the mailing list to talk about it, but it's not something I have opinions of off the top of my head. Check out hierarchical namespaces. It's got a certain amount of self-service options as well. We're busy rewriting the UX, but hopefully we'll be able to land that within the next week or two. But yeah, you can create a namespace that gives you a child namespace and copies a bunch of objects into it. So yeah, feel free to give me a shout. It's from our main page. Our main Git repo page, you can find HNC information there, and my contact information is there as well. The only other thing I would sort of ask is how, I asked about whether this was truly a planet-wide cluster before, and the answer was yes, but it also sounds like you can, in many cases, limit nodes to only being used by one team. And so I guess I was wondering about that, like in both cases, how frequently are people limiting nodes so that only they can run on their own nodes, in which case they're basically using the API server and the infrastructure, but are not really contributing anything back? And on the flip side, how often are people truly running workloads in multiple regions in the world? And the reason I ask this is because if you only have one cluster spanning the world, you have one failure domain. Anything that goes wrong with any of your components instantly affects everybody. And so it's often considered to be a best practice to have several clusters as long as it is not needed to deploy across them, because for that you need something like federation. So if it's rare that people are deploying in multiple regions, there might be an advantage to setting up regional clusters so that if something goes down, it doesn't take everybody down at the same time.
So I can say that we are in the very early beginning of our establishing cluster. So maybe we can provide better information after 6 months, 7 months, because now we are migrating PlanLab users into EdgeNet. So which means we will have a variety of users in the next months. So which will allow us to gather some data about your first question. But we also want individual users to provide their, for example, virtual machines into the system. So in this presentation, I didn't mention that, but we also want to, for example, we want to provide a system that individual users who provided nodes can enable and disable nodes according to the authorities in EdgeNet. So, for example, I just trust Lab Europe or Sorbonne University, and I want my node to be used by their team. So they will be able to do that by creating limitations in their node contribution objects. So I think this is an important case because this will be EdgeNet is a public infrastructure. So some users wouldn't want to open their nodes to everyone. So
I see.
for sure,
Okay.
because they would want to feel themselves safe. So.
Okay, so you really are just providing a Kubernetes control plane in that case to those users.
Yeah. Yeah.
Cool. Okay, thanks.
If I could just add one thing in response to your question, Adrian. The value of our system, like these previous systems, has to do with the availability of vantage points worldwide. And so the typical use is to deploy to multiple vantage points around the world. It might be that you're conducting internet measurements. And so there are certain things that you can only see from certain locations. Or you might be investigating, say, different ways in which intellectual property rights are applied on websites around the world. So you want to connect from different locations, things like that. Or you might be doing content, an experimental content distribution network. So in all of these cases, the worldwide distribution is very important, and we don't typically have people deploying to just a few nodes that are located close together.
Cool, sounds good. Yeah, and I guess as long as you don't have strict uptime requirements, that's pretty easy to manage as well. Okay, thanks.
Sure.
Should I move on to the next agenda item, Tasha?
Yeah,
Thank you very much,
do
everyone.
it. Yeah, thank you so much for that great
Yeah, thanks,
presentation.
everyone.
Super interesting. Cool. So we were going to have the operator lifecycle manager presentation. Daniel, are you ready to go?
Yep, I'm ready.
Cool.
Share my screen here. Okay, so hi everyone. I'm here to talk about operator multi-tenancy and the operator lifecycle manager. There's a couple of people on the team on the call, so feel free to reach out, ask any questions you may have as the presentation goes along, and I'm sure we'll be able to answer them. So to begin, what I want to talk about today is what is an operator, the operator lifecycle manager, the multi-tenancy solutions in OLM as they exist now, some of the problems that we have, some of the solutions that we have in the future, and some time at the end for discussion. So to begin with, to level set, I just want to talk about what is an operator so we're all on the same page. I think this is a handy graphic that just describes basically how the user posts custom resources to the Kubernetes API server and in a YAML specification, and then an operator watches for those events, for those custom resources coming in, and then reconciles them. And ultimately, operators are creating native Kubernetes resources in the core API. And so this is sort of a flow. And I imagine this is very familiar to most of you on the call, but I just wanted to get that out there. this is an operator. This is basically OLM's domain is operators like this. And so here's a picture of some of the operators that are available that are just providing a database. I included this just to show that a lot of the operators now that are going into people's clusters are, production critical. Like if you're running a web application and you want a backend Postgres database and you decide to provide it via an operator, that database has to be running all the time and it has to be stable. So these operators that people are installing into their Kubernetes clusters are really fulfilling critical infrastructure. So at a high level, that's what operators are. So what is the operator lifecycle manager then? The operator lifecycle manager provides control points for how and where operators are installed. If you want to install a one-off operator into your development cluster and just write some YAML and apply it, that's fine. But when you're talking about large production clusters, you really want to have reproducibility, auditability, and have better understanding of what's being put into your cluster. OLM also provides curation for what operators are available, sort of like repositories that you would expect in Debian or in other operating systems. OLM has this idea of catalogs that basically are catalogs of operators, and you can say, show me all the operators available in my cluster to install, and then it'll respond, and then you can pick one. So it's very similar to dpackage or Yum or those types of systems.
Where's that catalog hosted? On the cluster?
Yes. Yes. So there's actually catalog pods that are running that are able to, that have a gRPC connection open to a API service called package manifests. And you can say like get package manifests, and that'll reach out to those catalog sources, and then it'll return a list of all the different operators. And there's different catalogs. There's like the community operators catalog. There's the Red Hat operators catalog. You can make your own catalog, but essentially there's like a curated list inside the cluster of available operators, which is very handy because those are.
Okay, but the providers are not necessarily on the cluster. They're from some central repo somewhere else, right? Or can be.
Well, I think generally. Go ahead.
The operator isn't installed until it's requested to be installed. The catalog is installed.
Oh, okay. So somebody needed to install the catalog. And so somebody needs to update the catalog, for example.
Yeah, so I think the catalogs are basically like in apt sources, right? You're pointing to the upstream sources you're making available.
Essentially.
Okay.
Okay.
Yeah.
Thanks.
So this is Nikhil from OLM as well. It's typically it's a resource called catalog source, which we put a reference to a container image in a container image registry that gets pulled down and run as a pod, and that also like surfaces that gRPC API. So all the data is baked into those images that you reference in these kube resources.
Thanks.
So it makes available these catalogs of operators. It also provides a packaging format with metadata. We think about how do you package an operator. This is something we're working along with the sig-auth delivery team, trying to find a common format. I think we're settling on the OCI format of packaging operators in images, but then how do we attach all the metadata and all the information that we want around the operator? So OLM provides some kind of packaging format, and it also provides install and upgrade safety. So as I said, operators in your cluster are providing critical infrastructure. You want to be sure that if they change versions, that things remain running smoothly. And I think this is actually a key area. This is a complex area, but this is an area that OLM is trying to tackle actively. Upgrade safety and dependency resolution. You can have operators that depend on other operators. And install a suite of operators into your cluster at once and upgrade them in line. So this is really the core functionality that OLM is providing. This is just a diagram of some of the CRDs that OLM is working with. It's a series of 2 separate operators that are providing, that are managing these CRDs, which ultimately boil down to installing user-specified operators into the cluster. So yeah, at a high level, that's what OLM does. So talking about specifically multi-tenancy solutions that OLM provides currently, this is an interesting slide we pulled off Reddit. One user's recent experience talking about CRD lifecycle management. Basically, he's frustrated because there's inconsistencies in how CRDs are scoped and how they're applied. And I think this is one of the problems that we face often, and I know that other people in this working group face it as well, because they have some conflicts between the different CRDs in the cluster, and also how do you lifecycle the CRDs when there's new versions, and making sure that this sort of the upgrade process is seamless. So this is just one random person ranting on Reddit, but this is sort of a motivation for some of the multi-tenancy stuff that we have. So this is an email that Evan sent out, Evan's on the call, to this working group about a year ago, talking about our work with multi-tenancy. And so we came up with this concept called operator groups, which I want to talk about on the call. But essentially, we're working on, allowing users to independently install operators that are scoped to manage resources in their set of namespaces only, and trying to sort of encapsulate and isolate those operators from other operators. And when those operators manage the same APIs, this can cause resource contention, and as we saw earlier with CRD contention. But essentially, this is an example of some of the things that we were looking at last year. So we've been working on these multi-tenancy problems now for a while, with this group specifically. So these are some of the considerations that we think about in OLM when we think about multi-tenancy and operators. Many operators can be installed in a single namespace. Maybe that's the model that you're looking for. The operators can be in one namespace, and their operands, the sort of things that the operators are watching for, like the custom resources, they can be in other namespaces, in multiple other namespaces. They can be in any namespace. But essentially, you have this sort of many-to-many relationship between where the operators are sitting and where their operands are sitting. As I said, operators can watch their operands across one namespace, several namespaces, or all namespaces. And I'll have examples of this coming up that'll make it more clear. Operators can depend on other operators. OLM supports the idea of installing multiple operators together. And also, operators also have elevated privileges in the cluster, and not all users can install them. Operators change the fundamental behavior of the cluster, because the multi-tenancy currently in Kubernetes isn't strong enough to totally encapsulate them. So you have to be careful about who's allowed to install operators and sort of what actions they can take. So these are some of the things that we think about in OLM a lot when we're trying to establish, what our multi-tenancy solution can be for users. So this is one example when you have one operator sitting in a system namespace and it's watching tenants, watching all other namespaces. So this is sort of a typical example for something, in this case, like a MongoDB object, but maybe Prometheus rules. You're watching those across all namespaces. So this is one type of one installation mode. Another one is a single operator watching a set of namespaces. So here you have one operator and it's watching Kafka topics on only a series of namespaces, not all namespaces. And lastly, we have a one-to-one where we have a singleton installed in the cluster. And so all these configurations that I just went over are all powered by something called an operator group, which is a custom resource that we came up with within OLM to sort of help guide our multi-tenancy solution originally. And I'd like to talk a little bit about the operator group specifically to the group. As this is the spec. So as an object, it's fairly straightforward in that it's a small object. It just has some labels on it that basically explain what namespaces the operator group is targeting and what operators want to be a part of it. So this is the spec. I just wanted to show it to you that it's basically a simple looking object, but the actual explanation of it is something we're going to go into based on the docs. But basically what the operator group does is it tries to match when you install an operator, how does that operator know which namespaces to watch? Like if my operator is supposed to watch a couple of namespaces, how do I configure that at runtime? So this is based on the operator group. The operator group can inject into the deployment of the operator itself the set of namespaces that the operator is supposed to watch. And also, is an operator okay to install in this namespace? Like if I'm a cluster admin, I may be okay with installing operators in one namespace, but not another namespace. So this is again based on the operator group. And how does the user know whether an operator is watching a certain namespace? This is based on a custom resource in the namespace that the operator group is again propagating. So the operator group is sort of behind the scenes trying to enable this multi-tenant need that's inherent in OLM based on what OLM is trying to accomplish. So these are just the motivations of what the operator group is trying to accomplish. So the best way to explain it is we have a very nice doc that sort of goes over what the operator group is. And I thought I'd talk about it a little bit. We do have a little bit amount of time left though. But basically the operator group is, there's one operator group in every namespace currently. And the operator group is sort of responsible for providing the operators that are installed with that namespace a way of understanding what namespaces they should be watching and providing some explanation of whether an operator can be installed in a certain namespace or not. Because within OLM system, before you install an operator, you want to put an operator, before you install an operator into a namespace, you want to put an operator group in that namespace first. And that operator group sort of drives some of that behavior. And so if you have, for example, an operator that supports all namespaces, but you install it into an operator group, into a namespace where an operator group is single namespace only, then the operator installation will fail. So operator groups are a way to try to provide basic soft multi-tenancy within the cluster. And so I think I'll continue with the presentation at this point. But if anybody has any questions, we can come back to those.
So just to confirm, this is all public on GitHub now, right?
Yeah, absolutely. Yep, that was a public doc. I have the the slides are I have the link right here.
Cool.
They're in our doc design operator groups. It's a really comprehensive document, so I just wanted to link to it and say that check that out. I couldn't condense it down into a series of bullet points.
That's cool. Thanks.
Yeah, absolutely. So that's operator group is our one take on sort of the multi-tenancy aspect of it. So what are some of the problems that OLM is dealing with? Basically, one issue is that users don't expect to have to do upfront configuration of operators when installing them. Like if I see, a Postgres operator and I want to install it in my cluster, I don't necessarily think about, okay, which namespaces is it watching and which namespaces do I want to install it in first. I kind of just want to install it sort of like I, do pip install a Python package. I'm not thinking that much about it. So that's one design with operator groups that is a little bit, it front loads some of the complexity that users and operator authors for that matter don't necessarily want to think about. And another issue is that operators are not segregated enough from one another inside the cluster. Even if you install them in separate namespaces, their CRDs are global, they show up in discovery, and you can tell as a user whether they've been installed or not. And I think this goes back to that post that person made on Reddit. The isolation between operators and things that install CRDs into the cluster in Kubernetes now is not all the way to the level where we can make the sort of promises around operators, stability and behavior that we want. There's a lack of a first-class tenant model, which basically restricts access for developers to install operators. Generally, our view is that cluster admins should be installing these operators because they have a lot of power over what's going on in the cluster. But then again, the developer is the end user who wants to, make the custom resources and use the operator to fuel their application, which may be another operator that depends on those custom resources. So in a nutshell, installing a CRD affects the entire cluster, and this makes operator dependency and lifecycle a lot harder. So these are some of the problems that sort of we're encountering. And
one question I've wondered for a little bit, could you point an operator for custom resources at like an external Kubernetes API server, run one per tenant or something, but don't use it for deployments or anything, just use it to manage CRUDs. Has anybody explored that route?
Yes, I think we've talked about that. I think me, Evan, and I think we've talked about this recently within the past week or two, and I think this goes into what are some of the solutions are. I think we're very interested in both the virtual cluster and the HNC projects to think about doing this type of solution. I mean, Evan, you said you were looking at the virtual cluster solution pretty recently, right?
Yeah, we've definitely looked at this and talked about similar solutions, and the API server solution is an interesting one. Virtual cluster does a lot more than we really need for this particular problem. But yeah.
Yeah, so we've definitely looked at it. And essentially what we want to do is to encapsulate the operators on a cluster so that they can be safely installed and uninstalled as easily as containers can be started or removed. So sort of to your point, using another API server or something like that, anything that can sort of better provide a multi-tenancy solution is something that we're interested in. And in the long term, we're very interested in the multi-tenancy working group and some of the solutions that can come out of it, because it'll make our work that much easier. So yeah, that's,
if it weren't for the, sorry, can you hear me?
Yep.
If it weren't for the CRD issue, because CRDs are always global, it seems like the rest of it might not be so bad, because an operator is just a regular workload. And so as long as the operator has some kind of native idea as to which namespaces it is supposed to be operating, then as long as you set up all of your RBAC permissions correctly, then, which could be part of OLM, OLM could basically restrict operators to different portions of the cluster. It's really, I would have thought it was just the CRDs, the global CRDs, that really made everything fall apart. Is that correct?
I think it this is Nick Hale from OLM team. I think it starts to get complicated when you try to talk about where and how each operator is being used. Which slices of the cluster intersect for different operators that you've installed. Meaning, like, I can have an operator that watches all namespace, but only reacts to changes in a few of them, and how that intersects with another operator that has a similar or completely like different configuration for what it watches and what it does, and like these things cannot match up. And now you're managing the complexity of describing that, and making sure all of those things shake out when you're installing a set of operators to a cluster. Right. But it's definitely a multi-leveled problem.
Yeah, because it's almost like you might not want to give two different operators the same write privileges in the same, let's say, namespace, but you might not care if there are multiple that have read privileges.
Yeah.
Okay. Now the CRD problem, of course, is very hard to get around. I forget if I asked weeks ago, did someone talk to the API machinery group about this?
I don't know if we've done it yet, but we have some people on the OLM team attending the API machinery working group. So hopefully we will get in contact with them soon.
Yeah, Dan Smith is the right person to talk to there. Or the person, sorry, let me rephrase. The person I know to talk to there.
Back at the last US KubeCon, I also asked API machinery, what are the chances of getting some kind of named spaced CRD? And the answer was never. And then they pointed back at multi-tenancies, virtual cluster as a possible solution to that.
Yeah, I think that is hard problem. So that's the reason I'm stick to virtual cluster to solve, because we face the same problem. So yeah, before we're out of time, I'm just curious, does the OLM check the conflict of the operator? Let's say if two operators are managing the same pods, typically it may cause problem. Do we have any detection mechanism to avoid that?
So you're saying if two operators are watching the same custom resource?
Yeah, no. If the two operators are kind of that's for if they are, because operator typically watch for the pod label, right? If for some reason the operator watching for the same label, so one pod may be managed by two operators accidentally, probably. But is there a way to detect this conflict? Because sometimes if you install too many of the operators, people may, oh, I don't know, there is a conflict, the operator working on the same thing. Then the result is really just ad hoc. I'm just curious, is there any way to detect that? Because I sometimes face a problem. I see the pod has weird behavior just because two operators are working on the same thing.
Yeah, that's an interesting problem. I don't know off the top of my head that OLM has any support for that.
Yeah, I'm just curious.
Yeah, that does sound like a very bad scenario. That will lead to some undefined behavior. Yeah, so that's definitely bad.
Yeah, so because currently Kubernetes, there's no limitation. The owner reference can be expand as many owner as you can, and there's nothing to block a lot of things watch manipulate the same object.
So what we do have in OLM is the operator group that Daniel mentioned before allows you to say, look at operators, allows you to select a set of namespaces for which an operator that provides a specific API or CRD controls. And so OLM will never install another operator into that provides the same APIs and watches the same set of namespaces. It'll prevent you from doing that if you're installing with OLM. Beyond that, if you're just creating like deployments that manage or like kind of conflict with your resources and do some naughty things that you don't want, we don't detect that. I'm sure there's ways that there can be designs with some webhooks that prevent those sorts of problems. But what I just explained was the extent of what OLM does.
Yeah.
So if you're in our ecosystem, you are protected.
Yes. Yeah, I agree. I mean, because this is sometimes just developer make some mistakes, but I hope, in the high level framework level, if there is something can help, with this kind of thing, maybe it's just a wide idea, something that I have heard before.
I think it's a really good point. You can kind of take this a little bit farther though, right? It might be reasonable, like you suggested, to have an operator sort of own the management of a pod. It also might be reasonable for multiple operators to interact with the same pod, maybe managing different parts of it. One of them injects a sidecar, one of them adds a label, one of them does something else. And there might be also cases where it's fine for two operators to manage the same piece of a pod spec just at different times, and they hand off control. So I think it's a really interesting problem, and I don't think there's anything really trying to solve it right now. But yeah, it's definitely something we should start thinking about.
Okay. Yeah. Yeah. Good. Thanks.
Yeah, if nothing else, being able to configure it to do that would be good, but having some kind of default protections so that, if you just happen to accidentally get it into that state, it'll protect you from it. That would be good. You mentioned having to manage the operator groups. For our clusters, we've been keeping a Helm chart going for creating all of the tenant specific objects. So we recently just threw the operator group into that. So every tenant that we create just gets one now. So that can be a partial solution to it. The work group here is making an operator for tenant namespaces as well, and it could end up going in there.
Cool.
Yeah, cool. I guess we're over time, so.
Yeah, I think Andrew just left. So Tasha, so should we stop right here? I'll give it.
Yeah. Yeah, thank you for this presentation. It's super interesting. And yeah, if you could drop a link to your GitHub in the meeting minutes so people can check it out, that would be great.
Yep, absolutely.
Cool. Thanks, everybody.
Thanks. Good talk. Bye-bye.